Hello, everybody. Welcome back, and thank you so much for all who attended from this morning to this very moment. I think that we've crisscrossed a number of great discussion topics. We've actually discussed, even most recently, the subject of how technology in and of itself simplifies our life. I mean, if you take a look at even the perspective of how much information am I willing to give up, how much safety am I willing to give away in order to attain or gain more simplicity in my life. I mean, we're all inundated, or maybe in some words, over inundated with data. And how do you control that data? How much of it can I use? How much do I need? But how much do I want to give away? So with all of that, there are a number of things on Whova, which I imagine well by now, every one of you have been well introduced to. And like I said, there are some intrinsic qualities to Whova that you can actually guide and steer yourself through that, and you won't hurt the system. Just explore it, and through that exploration you'll find a series of poll questions that have been answered, and there will be others through the rest of the day and tomorrow. But when you take a look at the polls, you'll discover what kind of subject matter were we actually covering. Everything from automotive conditions relative to technology, autonomous vehicles, in other words, innovation, quality of life, safety, and how all of these things amazingly intertwine. So please check that out. Right now, we're getting ready to embark upon another subject that's going to be brought to our table by Hannah Walker. So let me speak about Hannah for a quick moment. Hannah is a technology designer. She's with Sinclair Holdings LLC, and she's going to be discussing the development of a connected building. Hannah is the in-house architectural and technology designer for Sinclair Holdings LLC. She's a graduate of Texas A&M with an architecture degree from in 2017, and then joined Sinclair just after that to help design and implement smart building technologies. During employment, she retained a CCNA certification at TCC, and has been using both her networking and architectural degrees to design and develop smart building spaces and infrastructure. Sinclair Holdings is currently developing a historic project in downtown Fort Worth that will be the most advanced low voltage DC powered building in the world. And one of the leading questions that actually comes up when we start discussing what she does and how she does it with regard to Fort Worth. Let me read this because it'll be a good segue into her discussion over the next 50 minutes. So what does it mean to have a connected building? In Fort Worth, Texas, the Sinclair Hotel is the most advanced DC microgrid building in the world. Learn how we utilize PoE technology and advanced DC power distribution to increase energy efficiency by 35% and create a connected building network that enhances the guest experience and makes operating and maintenance easier. So here again, we're talking about the induction, the utilization of technology, and how it makes things easier. What those things are, well, it depends. It depends on what the use is. And so I believe that Hannah is going to be going deeper into that subject matter. Hannah, I see you on the screen. Thank you so much for joining us. And if I could just ask you to take yourself off mute, and that way we don't lose a word that you say. And so thank you again for being with us today during this lunch hour. Looking forward to hearing all you have to share with us. Again, here you go. Thank you.
Thank you for that introduction. Had some iffy background noises without mute on, so I just wanted to make sure you got everything out you wanted to say. But thank you for having me. It's been I've gotten to hear some of the presentations throughout the day, and it sounds like there's some really interesting things that people are working on all throughout Texas, and we're happy with our projects in Fort Worth, how easy the city was to work with, and the acceptance of this digital building technology has been really powerful in the Texas area, especially in the DFW area. So I'm going to share my screen here, and we'll kind of jump into the things that we are going to talk about today. So I'm going to present right there. Okay. So I'm going to start a little bit about just, about me, what we do. So my name's Hannah Walker. I have a architectural degree from Texas A&M for my undergraduate, and then started working in this digital building space. I was working for a developer, and we've been developing hospitality projects. So we have 3 hotels currently. And how this whole thing started was, we had the typical developer problem. We put in an advanced lighting system. We had LEDs, energy efficient, etc. We purchased a lutron dimming solution. And if you're familiar at all with lighting controls, you know that they can be challenging and kind of frustrating to put in. And so from when this system got implemented in one of our previous properties, the lighting controls never worked a single day. And we had already had all our sheetrock ceiling up. And the lutron engineers were saying, finger pointing to electricians, saying that you wired it wrong. And the electricians were finger pointing to the lutron engineers and say, well, you designed it wrong. And then, but nobody would take ownership of the fact that the system we paid for was not working, and they were going to have to tear down the entire system, ceiling, to fix that. And nobody wanted to take ownership of that. And so when that happened, the owner of the company said, there's got to be an easier, simpler way to have lighting, to have control and power in a single system to an endpoint. And that's when he learned about PoE and the powers of PoE and what it can do. And so I'll go ahead and take you into the property that we had just completed called the Sinclair Hotel. So one of the topics that Carlos mentioned was, what do we talk about when we're talking about a connected building? And when we mean connected, we mean that all of the endpoints in a property can communicate with each other in order to make informed decisions. And so you kind of see some of the endpoints that we have there. And this is a vision that was started up about 3-4 years ago and was embraced by all the companies that you see on the screen. So we have been engaging with LG and Marriott. It's a Marriott property. And so a lot of people are starting to really believe in the idea of this DC low voltage building. And what does that mean? And why does it make so much sense logically? So I want to start with talking about what is PoE power. And so PoE is power over Ethernet. So the same kind of cabling that you would use to connect access points or cameras or even your desktop to the internet is an Ethernet cable. And an Ethernet cable has 4 pairs of wires in it. And 2 of those pairs can pass power and 2 of those pairs can pass data communication. So you have data and power on the same exact cable. The benefits of it is that you don't need an electrician to install it. It's considered class 2 power. You cannot be shocked by it because it's low voltage. It's an Ethernet cable. It's the same one used to plug in your computer and your IP phone. And the thing about appliances and lights and window treatments, all of those devices, almost every device that we have today is DC power on the inside. And so by powering it with 120 volt AC or 208 AC power, we have an energy efficiency loss there, and that comes out as heat. So you're creating heat and you're losing energy and you're losing efficiency when you power them that way. By powering them with PoE power, you're powering them directly with DC power. So you're running a control cable as well on the same cable, and you're powering it, and it's more efficient, and now you have data communication. So Cisco's been working on this for a little while, and they can now do up to 90 watts of power on one single cable. And so we've been able to, the advancement of the increase of PoE power has allowed lots and lots and lots of endpoints to fall in the range of PoE power. And we'll talk about that a little bit more. So the first thing that we tackled was PoE lighting. We talked about the classic problem. You got your AC circuits going to your lights, and then you have to run a separate control cable that's usually from a proprietary system. Only their engineers can fix it. They'll cost you an arm and a leg to do any kind of commissioning. So PoE lighting was the first thing that we reached out to. So every single LED light can be a PoE light because it is a DC LED light. And so what we do is we remove the driver from the light, and then we use a separate driver that can be PoE power, and then we send DC power to the lights. And the benefit of that is that you can have a single driver, and it can connect all the devices that can make up to your 90 watts. So then you can put, 10 lights, 12 lights on one driver instead of a 1-to-1 distribution. So the next thing that we wanted to tackle in the guest rooms was this whole idea of, in order to make these spaces more efficient, how can I accurately tell that somebody is in a guest room? So when they're not in the guest room, I can tell my lights to shut off. I can tell my other devices to shut off. And so we started reaching out to this company called Ivani, and they make a Bluetooth mesh sensor. And a way a typical motion sensor works, and it's extremely inefficient. I'm sure everyone's been into an office or some other situation where, you stop moving, you're watching a presentation, suddenly all the lights go off, you're waving your arms around, they're not coming on. So Bluetooth is not that kind of motion-based technology. There are two things that stop a Bluetooth wave. And there's Bluetooth in everything. There's Bluetooth in your phones. There's Bluetooth in so many devices now, and it's just so widely used, which is why this is a great technology to utilize. So water and metal stops Bluetooth. And so if you have a set of sensors in a space and you walk through those sensors, then your body, which is made up of mostly water, will disrupt the mesh. And so this way, they use pattern recognition to recognize that now a person has walked into this mesh, or two people, or three people. And so you can really, truly now get an exact understanding of, is a space occupied or not? And for that, we talked about the occupancy detection, we can do people counting, we can put a geofence around a space. So if somebody walks out with some kind of very expensive product, they can be alerted. We can also put tags, Bluetooth tags on devices, like housekeeping carts. Drills, we operate hotels. We know that drills somehow get misplaced sometimes. And so all of this we can do now with Bluetooth technology. And now we can start to really make our spaces more efficient that are not occupied. Because if you're familiar with the hospitality industry, you know that it's one of the most inefficient industries because it's all up to the guest. They could leave all their lights on, they could leave their TVs on, they could leave everything on, and nobody can go in there and turn them all off. But now with this technology, we can create more efficiency in our spaces. Another item that we wanted to make PoE was we wanted motorized window treatments. And so when we took this idea to Somfy, they thought it was a fantastic idea. And the reason that large businesses are coming on to this idea is because if you think about it, if you're a global company like Somfy, you ship product all over the world. Today, you have to send a different product to every single country because they all have different power requirements. European power requirements are different than American power requirements. And so they've got all these part numbers, but PoE power is the only universal power standard. And so I can make one PoE power window treatment and I can send it anywhere in the world. And that is a great business advantage for large companies. We also reached out to our minibar manufacturer, and they were able, Dometic makes a refrigerator that has no refrigerant, doesn't have a compressor. It uses solid state cooling, which is the technology that's very energy efficient. And because it's energy efficient enough, we can power it with PoE and completely remove that circuit from our guest rooms. So another item that I wanted to talk about today was, so we're talking about PoE power. We understand that we're going to do network switches now to give us power. So we're going to, put these networking switches around the space, but how do we power those network switches? Those still require power, right? And so, but what we're doing is there's a technology out there called VoltServer, and you might be familiar with their technology. So they're in every single NFL stadium today. And what they do is they're able to send large amounts of DC power, a very long distance across a class 2 wire. And so what they do is they take AC power and then they pulse it down in packets of energy down an 18 gauge wire, and they can send it up to 2 kilometers without any power loss. And they can get up to 1,000 watts on a single 18 gauge cable. And because they're pulsing it and they're checking for faults and breaks, and it's only sending, every pulse is only 9 joules of energy, which is extremely low. So you cannot be shocked. It's safe to handle. It's class 2 rated, so an electrician doesn't have to install it. So we use this technology to power all the distributed switches in our building. We have about 350 distributed Cisco build switches in our project, and they're all powered with this technology. So that means that I can put one centralized server in a basement of a building, and from that point on, I can power all my lighting, window treatments, window shades, mini bars, and smart mirrors for the entire project from one central location, all on class 2 wire. So from that point on, I don't need an electrician to run a single cable to any of the endpoints in my entire building that I've been able to create onto low voltage DC. Another thing that we were interested in this project, we said, we're putting all this energy efficient technology in. It's a high rise. We still need to have UL 924 emergency backup for elevators, stereo pressurization, emergency lighting. But the only thing available, there are some battery systems available today, but they're all lead acid batteries, and they take up a huge amount of space, much larger than a diesel generator. And so the other option, diesel generator, standard, requires a lot of maintenance, which, spoiler alert, most people don't do that maintenance. It requires to have fuel on site. It requires a lot of ventilation out of the space. It's very loud. So we were thinking, diesel generator in a, smart building project doesn't really sound like something that we're interested in. So we started looking into lithium ion solutions, and there actually wasn't any available. But we have a very strong partnership with LG. We're working on some other projects with them as well. And we were able to find a system that they have in Korea that's used all over Korea for peak load shaving that they use. And it's called the ESS system. So this system is actually very similar, and it has another UL certification. It was very similar to what we needed for UL 924. And so we were able to convince UL, the head of UL 924, to come, which is Michael Schulman, and he was able to send an engineer out to Korea and make sure that this would fit into the UL 924 category. And it passed the test there. They shipped it to Fort Worth. We installed it into our space, and it got its UL 924 stamp at that time. And so this is the very first UL 924 lithium ion solution. And LG has become so excited about, why haven't we been doing this? Because it solves so many problems for buildings. It's compact, it's modular. It can go down the elevator. You don't have to have a huge hole in the sidewalk. You don't have to have the fuel. It has no maintenance. It's gonna work every single time. It's you can change the battery packs out as they fail. They have a 20-year life on them, and you're not gonna have situations like New York and different power outages that you see in California, and half the generators don't turn on because they aren't maintained. And there's actually a code right now in California that fines people for running their generators. But if they don't run the generators, then they're not going to work. And so people just decide, well, we're just not going to run the generators because we don't want to be fined. And so this solves all of those problems in one battery solution. So I just wanted to show you a few other of our projects that we've done. So we haven't done only hospitality. We did this office building, which I'm in right now, and you can see on the screen. It's 8 stories, but it's not all office. But we did all of that POE. We started with that was the first project 4 years ago to get our feet wet and understand a little bit more about the system. We did a CVS also in our building. They wanted to come in and take advantage of our great downtown location. And we said, well, POE and LGVRF are the standards. And they said, well, we've never done that before. And we said, well, that's what it takes to get in the building. So they let us do all their lighting, POE as well. And then here's just a few photographs of our Sinclair project. And one thing that I wanted to highlight was there is kind of a rumor that started by some of the, lighting reps and people that just don't know as much about the system, is that there's only a handful of fixtures that can be POE. There's only these ugly 2x2s and architectural fixtures, but we're kind of coming to the forefront to say any LED light can be a POE light. We have to work with the manufacturer, and we've partnered with a lot of manufacturers to make any kind of lighting that you could possibly want into a POE light. And so you can see there's a large variety of fixtures in our project. Here are guest rooms, all POE. None of it, all of it was able to be produced as a POE light fixture. Another thing that I wanted to talk about was this is becoming more and more prevalent in today. We're not the only ones that are doing this. We're not the only ones that realize, wow, this is super efficient. I can save 35% of my energy. I can reduce my building load. We're now after we've developed these projects successfully, we've been able to offer our services to other developers because, we understand, we went through it, we learned how to design it. And so now we help other people develop their own projects. And so this building you see here is a project in New Haven, Connecticut. It's also going to be a hospitality project, also historic renovation. And this is actually going to be, it's going to be a passive house building. It's going to be the first net zero hospitality project there is. And so they're able to utilize a lot of the smart technology that we've designed for them. And because we're saving so many efficiencies with the energy conversions, they're also using a battery system. They have a ton of solar. You know, they're doing a lot of amazing things. Their whole kitchen, you know, everything is Energy Star. They're using extremely energy efficient windows and things like that. But this is going to be a net zero building. And I think that this is going to become more and more common when people realize that using DC technology in a building instead of AC can really get you down to the level that is possible to have a net zero building. Some other projects that we're working on this project currently, we're working on a senior living project in Huntsville, Alabama, which is going to be really interesting. We're outfitting the entire property with circadian rhythm lighting. And so as a senior care facility, there's been so many studies that have been done about the benefits to your health, wellness, your mood, your emotional state for circadian rhythm lighting. And so the lighting will be changing throughout the time to the color temperature so that people that are, you know, nowadays you're staying indoors a lot more, you're isolated. But with this kind of technology, you can help keep your body and your emotions, you know, more on the positive side. We're also working on converting other systems to PoE for that project. And we're continually doing that in the future. Right now, we're working on doing all of the HVAC into PoE system. So for this project, that'll be the case where the lighting, ceiling fans, HVAC systems for the entire project will be run off of PoE power. So we don't actually need to have an electrician in our residency units for the ceiling. Sorry, in the ceiling, there's still convenience outlets and appliances, etc. But they will not be wiring anything in the ceiling. We're having low voltage installers do the lighting, the ceiling fans, everything, because it's all low voltage power. Other projects, you know, that are kind of local and also not local. Microsoft headquarters in Seattle is going all PoE. You know, that's over 1 million square feet. I mean, that's a huge project to go PoE. In Dallas, the Samsung offices, they're going PoE. Round Rock ISD, they're doing a PoE project right now. We're talking with TCC, a local community college here. They want to explore this PoE technology. There's another hotel project in Fort Worth that we're not doing, but it's in our area. That's also going to be going PoE. This is a list of projects in New York that are all going PoE, and you can see, you know, a variety of ecosystem partners. But this kind of idea of what is a DC building? How do I do it? There are enough use cases now to people are actually putting into practice. You know, we have the hotel, we've got several office buildings. All of these projects are going PoE because they see how much energy we can save, how sustainable we can be, and why the connected building makes sense. You know, if a light goes out, it can tell me before I have to go and, you know, see that it's out. You know, I can now, when a guest leaves the room, I can, you know, lower their thermostat. I can turn off their lights. I can, you know, lower the shades to the optimal setting, whether I want to do solar gain. And all of that is very simple. I mean, these are things that we could do before, you know, if we would have paid tons of money for the control system. But with this digital building technology, it's so simple because it's all on a network now. And I can have one screen that I can control my whole building from. And so, you know, we are in the strides to going for a complete DC building where we've got a little ways to go, but we're really excited about, you know, our partners and what we've been able to do so far. And we're right here in Fort Worth if anybody has an interest in coming to see the project or some of our other ideas. But that's the end of my presentation. So is there any questions?
Thank you so much, Hannah. You know, I'm curious, and I'll go ahead and start the questions as others pour in. Number one, thank you so much for joining us today. And can you see me, by the way? Am I on your, I'm not, am I? Here, let's do this. Here we go. There we go.
Am I still sharing my screen? I'm trying to not do that. Okay.
You can leave your screen on. It's all good. It's not going to hurt anything. We're rolling. In fact, it's not bad to have that as a background, to be quite honest with you, because there's a Sinclair right there. You may find even in our our discussion as I moderate this session before our next break, that you may need to go back to some of those screenshots and so on. Probably one of the most immediate thoughts that come to mind as I listen to all that you presented is, obviously you're providing this service for this product, PoE, and what the end use is. In fact, you might need to turn me down or turn me off on whatever the device you're using. And that way there's no feedback. Anyway, when you take a look at the senior living project, for instance, that you were talking about just moments ago, how did you go about, or how did the group that you're with go about in convincing this client, that client, that this was either the right way to go, this was a paradigm worth investigating and therefore buying into? What were some of the critical concerns that they had as an end user, and the end user being their elderly residents and their families being able to engage such technology in a facility that they would be living in?
Certainly.
How did you all get through all of that?
So when we first started approaching the project, we were actually brought to the project.
When I got onto the app, it took my audio.
Hey, Charlie, can you mute? I'm sorry.
I don't know why.
No problem.
Okay, I got to do this, Dave. I can't mess with that right now.
Whoa, 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 Charlie. Charlie needs to be on mute. Okay. Roll, Hannah.
Okay, cool. So we were actually brought to the senior living project through one of our partners, which is named Igor, who does the lighting controls, and they design the system that will control the lighting. But for this senior living project, what we find typically from our clients is, one, they are interested in sustainability. They're interested in obviously OpEx, capturing extreme energy savings over time. This system, we do feel that we can be either equal to cost on the CapEx as well, if it's done and designed the right way. So it should be the same CapEx and save you considerable money over time. But they were also interested in, for this particular project, they have owned several senior living facilities. And if you're familiar with that market, the standard for technology and the way that they build senior living care facilities is not very high in a hospitality setting where we're kind of fighting and competing for the best experience. That's not a huge priority in senior living. And so when they saw that we were from hospitality world, they wanted to offer the same kind of high-end experience to their customers and be able to kind of capitalize on the fact that we have all this technology. Why are we still using, in a lot of senior care facilities, they still have like physical pull cords that somebody has to pull, to get attention. And they were kind of thinking, one of the owners is in technology, and was saying, there is so much technology. Why are we not utilizing this to maximize our guest experience? One thing that we're doing there is they're going to be able to have, it's like a keyless entry for your car. You carry a device, which is for keys. For cars, it's your key. Similarly, you'll carry a device, a key for your front door, whether it looks like a bracelet or some other system. And you'll be able to walk up to your front door, and the Bluetooth will recognize that you have the tag, just like you would have a key, and you can open your door. But that tag will also double for, you can click on the tag now, and now anybody can be alerted that you need assistance. And so we're utilizing technology that is already very prevalent in the world today, but making it into a senior living deployment. And so, when they brought us on, those are some of the things that they were interested in using, and understanding how technology can kind of catapult an industry that is traditionally very, very low technology. And as far as one thing you asked about was, how do the guests interact with the technology? And as far as the controls on the guest facing side, there are a lot of things you can do. In our hospitality project, we have touchscreen panels that we can customize to say anything, because now it's all on a network. So it doesn't have to be physically wired into a light. It can be wired into anything you want. But there are still ways, and in this project, we will use almost all traditional wall controllers, just toggle buttons that we're just tying into the PoE system. So to the guest, it's going to feel very familiar, but they'll just be able to, oh, by the way, you can also control all your lights and your fans and your shades on your cell phone too, if you want to, and so that gives them that flexibility. But if they aren't as embracing of technology, they can still utilize their spaces, the exact same as they would at another facility.
So what other platforms have you gone into? I mean, we're talking about senior living in this respect. We're talking about hospitality and the crossover. And certainly we can see this in office buildings, no question. How about healthcare hospitals and things of that nature? Have you all been going into those venues as well?
So we're still, young company as far as designing for other people's projects, but we've had several, we have a lot of visitors here that like to see the technology, and there has been a lot of interest in the healthcare world. I think as far as just a simple thing like Kelvin tunable lighting is really interesting because, if you're in a room and the doctor's there and he needs to see everything very clearly, you can have a nice cold light, which is typically what you find in hospitality, but, they're gone and now the patient's in there, so they would prefer something, warmer, or if they're bedridden, maybe that you can get the circadian rhythm to help their attitude and their mental health. And they're also in this project, the senior living project. The next project will be assisted living, which is kind of stepping into healthcare a little bit. And we're going to be installing heart rate monitors, all run off of low voltage, so that the property and family members of the residents can be alerted if there are issues with heart rate and things like that. And so I think there could be a lot of advantages to going into the healthcare world, but and we will kind of be stepping into that when we do assisted living, but we haven't done, a full scale, hospital or anything like that.
I've got a question from the audience, but before I go to that, I want to kind of tie the two things together from what you just said to what this question is that I see on my screen. And the question is going to deal with redundancy. Mm-hmm. As we take a look at, I'm a healthcare architect, for instance, so I do everything from senior living to the inpatient side of the healthcare spectrum as well, when we're talking about hospitals, clinics, and so on. When we talk about redundancy, sometimes there are state equivalents of, let's say, by code or by virtue of what has been mandated by the state authority having jurisdiction, that there is still that hardwired redundancy factor still installed. Yes, I know that I can go wireless. Yes, I know that I can take a full advantage of telemetry and so on and so forth. But when we take a look at PoE, what is the backbone of safety when some things on the intelligence side go wrong or disconnectivity occurs? What, as a client or as an architect serving a client and trying to counsel my client, what are those things that I can share with them about the redundancy factor?
So the advantage of PoE versus some other technology systems that want to go all wireless, that is kind of a push that everything is wireless, and that's one of the issues that we kind of try to address with PoE, is that it does have a physical connection to most of these endpoints. It is a low voltage connection, and you don't need an electrician to run it, but it is still a physical connection, because when you're talking about data communication now amongst 20 devices in the room, you don't want to have this wireless issue where there's loss and drop of communication and things are not communicating. When it's all hardwired into a network, the communication becomes much simpler. Now, when we talk about redundancy, there's a lot of things that we do on the network side to keep things that are important up. And so one thing that we do at Sinclair for all of our emergency lighting, we have the specific systems that are, all the switches that are tied to those systems you want to keep up, like emergency lighting. Those are tied into that ESS battery solution. So now there's a power outage. Those lights all stay up, and the other ones that are not as critical, those will fail, will go down with the power outage. So there's a lot of ways that you can back up the systems that you need, just like a normal data network. If you have a data network, you'd back up your server with UPS. You'd back up certain other things like this phone system.
So it would be the exact same thing here, where you would identify the components that are important to have redundancy. We do a lot of things with our network side, where we have 2 switches that are kind of aggregating everything, and we feed them through 2 different rings. And so if one fails, the other one's still running and nothing is going down there. And so there are a lot of things that we consider when you're talking about taking life safety systems, especially, and moving them into the IT world. There's a lot of codes you have to follow and be aware of. And so we work very closely with electrical engineers and the operations to identify, what do we need to do to make this, perfectly operational in any emergency situation, or if there is a switch that goes down, how do we address that?
Very good. So now let's go to the question, because it goes to the flip side of all of this. And it's fairly simple, so I'll just read it as such. What pushback have potential customers relayed to you? In other words, why not use PoE?
Right. So we deal with a lot of, and one of the issues is when you go into an organization and you want to make a big change like this, there are a lot of parties that typically have to get on board. And so you have in one corner, you've got the facilities guys that are going to be maintaining this. And if they don't feel really comfortable with, they usually have the IT stuff, the IT stuff. The maintenance stuff is the maintenance stuff. And I take care of this and they take care of that. So if it begins to get some concern on their side about how do I maintain this, I don't feel comfortable with this, then we do get a little bit of pushback there, just off the start, and then we get some pushback sometimes from even the IT side. So it's funny because we're giving them, theoretically more systems, more switches, but they have an idea about how they typically do an architecture of a building. They like the centralized rack mounted switches where you run all the cables out, and they don't want, anybody in there, and they want it just to be their closet, and they lock it and nobody's in there messing with their stuff. And so when we start to say, okay, we're going to have distributed switching, we're going to, do this and this, and try to make this, a good incentive for an operator, then they start to kind of, we have had some pushback with that as well. If it's designed inefficiently, it can be extremely ineffective. But another thing to consider is a lot of people, so you can't separate the controls from the PoE. So if you just want an on and off light, you don't care about dimming, you don't care about communication, you don't care about tying it into the HVAC or the window treatments, you just want a light that turns on and off, then PoE is not going to be cost effective for your building. So that is one thing that gets, I think, when people hear that it's cost effective, they want, okay, well, I want the barest minimum that I can possibly get. But I can't separate the communication out of PoE. It's built-in communication power. So if you don't want the communication, then it's very hard to justify the cost for a PoE system.
And justifying the cost, I mean, ultimately you're talking about the ROI. What's that return on investment? And when you take a look at it from an equation, if you will, that return on investment is the answer. So what is the problem? Well, the problem is going to be relative to, of course, cost, what you just indicated. Do I really need a PoE? Do I need anything less than that PoE? But let's also talk about something you did touch upon just a little bit ago, and that's the training, okay? So if my facilities management team is of the following, well, I've been doing it for 40 years this way, why would I change, right? Or scared of new technology, just not able to embrace, the latest and greatest of what it is, what it could be, regardless of what it could do, regardless of who it'll serve. I'm just scared of it. And the other thing is, just taking a look at it from an ongoing management standpoint. Okay, so if it's a high cost going in, what is then the ongoing cost of its continued management? I'll go to one of the questions that has just been asked, and that is, when we take a look at city maintenance, that team, the team of people that run city management of their systems on a day-to-day basis, and they're not fond of anything new, and they're concerned about their staff learning new technologies, how do you address that? What is the what is that lifeline, for lack of better terminology, what is that lifeline that you give to your clients who are scared or have teams that are just not ready to make that jump? What is that lifeline that you give to them to actually get them to the other side?
So this is a question that comes up a lot because it's a big change for the facilities industry, and we see it a lot of a similar change that's happened in the automotive industry. Cars have advanced in technology, tenfold, and there has been a new level of education to a car mechanic. You can't just know this standard, diesel, gasoline powered engines. You have to embrace the fact that things are changing. Electric vehicles, cars are getting more and more technical. This is another side of the industry that's coming up. And I think this is a very similar thing that's happening to buildings. Even in a standard building, there's a lot more automation today than there was before. The building automation systems, those are very standard in projects nowadays, and they can be tricky to manage. And so one of the reasons that we are interested in POE is because it makes those things a lot simpler, because you can have a dashboard that tells you exactly what is going on, exactly what's wrong, where the issue is. It can do some analysis for you and start to help you figure out what the problem is. And a lot of building automation systems that we come across are tricky because they're proprietary and they're kind of confusing, and you can't do a lot of work on them if you're not familiar with the system. But we work very hard and closely with our partners to make it very simple. And software is a great way they put a lot of money into the software to how it looks. And we have a switch partner that we're working with right now that as soon as you plug a device in, it makes a graph for you. So you physically see the switch on the plan, and it pops up port 1, and there's a little light icon and say, this light is in this port and this light is having an issue. So I think the answer to technology, how do we address more complicated technology? The answer is also technology, ironically, because technology can solve the problem of how hard is it to operate. And with our partners, and this is something that we've been very selective of partners that can make something that anyone can manage. It doesn't have to be a technical person, it doesn't have to be somebody who has a CCNA or, a networking degree, because you're not putting, all those layers of security and et cetera that you would on data switches, because now the parts are just communicating with each other. They're not access to the internet. They aren't, passing television streams. They're much simpler networks. And so we feel that, just with the work we've done to make these products simpler and more manageable, that we've been doing a good job so far. With our hotel, class example, Marriott doesn't have any other properties that operate like this. But after a few weeks of training with the team, they stopped calling us, because they've been able to learn it and take it on, and they've actually been really excited to learn a new skill set because it makes them a lot more marketable.
And I think that from right there, and I'm so glad that you brought that up, because now you're talking about, we've gone beyond the enter here line, and now we're using it. So from that perspective, what are some of the lessons learned, if you will? Whether it be, gosh, Hannah, we just had this eureka moment. We could have been using this 20 years ago. I wish we had known. Or, gee, Hannah, have you thought about maybe this system being able to do this, that, or the other? Conversely, gosh, Hannah, it's just, it's more than what we anticipated. And maybe if we had waited 3 years before its implementation, maybe we should have done that. So can you speak to some of those things, particularly from a lessons learned perspective, because your audience is not only represented by architects, engineers, and contractors and so on, but it's also developers, owners, those who are actually the ones that need to be engaged relative to this new paradigm, if you will.
Right. And we had the benefit of, we owned the building. And so we made the decision that we are going to go this way. And even if, it hasn't been 100% every product being vetted, we still put it in. I mean, we we didn't know if we were going to have PoE mini bars. So we put an electrical outlet behind the mini bar slot, and then, oh, they were able to get it. Let's put it in, So, we were kind of that risk taker and putting a lot of systems in that hadn't been combined together before. And with that came a lot of lessons learned, definitely. Just simple things on design. What we decided to put our switches inside the rooms. They're fanless, plenum rated, no noise. You don't even know it's there. It's in the closet behind the secret panel. But we realized that when you maintain these, you now have to disturb the guests to get in the room. We were able to achieve shorter distances with our cable lengths. Less labor, less cost on that. But it makes maintenance a lot more difficult because I have to go in there, and if there's guests in there, I have to disrupt the space, So now we design things, we put them in the corridor. And, with the same in-room deployment I was talking about, we had a switch that was shared in every other room, which then that was an issue because if there was an issue in one room, sometimes I had to go into the room next door to fix the issue. So some things that made a lot of sense logically with cost and design didn't actually make a lot of sense when you implemented it. So, there's a lot of things that we learned. So many things we learned. I mean, just even with cable types, we have our conduits that go in the verticals for running our digital electricity cables. And we use indoor cable because it's inside the building. But then we had a roof leak on our third floor roof, and it got into the conduit. And then we completely ruined, a huge bundle of cables that made all the switches, in construction, they all started restarting and flashing, and we didn't know what was going on because we didn't know that water had gotten into that conduit. So from that point on, we're like, all right, that we're going to use indoor-outdoor cable from now on in these kind of situations. So there are really a lot of things that we learned and a lot of great lessons learned. And so that's one of the reasons that we feel more confident designing other people's buildings, is because we've learned so much with our own projects and ways that we can optimize the design and the communication between partners.
So let's take this now. We began this conversation following your presentation on, in your presentation, you spoke on what it was, what it can do. Great. We talked about the return on investment. We talked about the people not only using it, but we also discussed those who would be on the implementation side in terms of managing it, from an owner standpoint, from a facilities manager standpoint. And now you've discussed the lessons learned. When, as you very well know, technology advances, and I think that we had all talked about a little bit ago. In fact, I think I mentioned that the advancement of technology, it's not an incremental growth, it's an exponential growth. Somehow it's able to compound on itself just by virtue of what it is and what it's always been. It's technology, and we're able to make things smaller and smaller and smaller and smaller. Well, having said all that, when we take a look at equitability, when we take a look at this system being used by the masses, let's take it to its most common denominator that we're all connected by, and that is our homes. Is the PoE a platform by which our own residences would utilize such a backbone? I mean, I can certainly see it from a senior living standpoint. That's a home. You take it to a hospital, that's a home. Temporary or hospice, that's a temporary home because that's end of life. We take a look at offices. Well, some of us actually stay at our offices like their homes, unfortunately. But we now take a look at life today. We're in this pandemic. Much of our lives today are bound by the four walls of our houses, and our houses have become our offices, and that wasn't part of the plan. The plan was not that I would be setting up a card table in my master bedroom so that I can actually run my office on a daily basis out of my bedroom. But that is essentially where we are. I can go back to, and none of this is to be about me, but I'll mention this real quickly. My master's thesis back at Ball State University was based on working at home. And so the deliverable complement of technology being able to allow me to not have a physical office anymore. And I can actually go to a swing space if I needed it to physically conference with somebody, but more times than not, I'm doing all of my business from my house. So without me saying too much more, where have y'all been thinking about the usability, how commodious, if you will, is this platform for even taking it to a residential venue?
So we have been actually talking to a residential home builder in Arizona, but I think the most compelling thing about this technology in the residential component is the fact that the residential load, energy load, is so much less than a lot of other spaces, to where I think that today we have the technology that we could be building, net zero homes that are off the grid. And the technology is still a little expensive, but everything that we've done, we're working with LG a lot to do solar, store it into a battery, put it into a PoE switch, send it to the light. You have a single energy loss in that entire loop. That's going to make your home, so incredibly efficient. And then now with electric cars, we're talking about installing car chargers that have bi-directional charging. So now you come home from work, you park your EV in the garage, and there's a power outage. Well, now I can load shed the loads I don't need because it's all an intelligent system. I can load shed all those loads. I can pull energy from my car because I'm using a bi-directional charger, and I can keep my life safety systems on. Maybe I want to prioritize my refrigerator because it's got my milk in there and I don't want it to go bad. I can prioritize, it's a nice day, I don't need my electricity or my HVAC. So I can just, get on my iPad or my phone, I can just load shed those things intelligently. And so for homes, I think that it's so compelling what you can do realistically today. And we're working with LG right now. You hear the term inverter-based appliances. And, what does that mean? That means it's all DC on the inside, and it's inverting the AC power to DC power. So these appliances they're making are basically ready to go DC products. So we're working with them to send some kind of DC power, whether it's, digital electricity, whether it's just high voltage DC, whether it's low voltage DC, and power the appliances directly. And that's going to use a lot of cost savings there. We talk about things like your outlets, your receptacles, you still have receptacles, here and there. So the volt server technology has a system, it's got a transmitter and it has a receiver. In between, it's class 2 pulse power. The receiver, though, they have many types of receivers. They can do receiver that outputs high voltage DC, which is what we're using at Sinclair to power our Cisco switches. It has an output for low voltage DC, which we can use to power other types of devices, including switches from other manufacturers. It also has an output for AC power. So I can store, my energy with my battery. I can move it into volt server, and then I can pulse it, low voltage to a receiver. And then I can just use a whip that has a little plug, and you send a little whip down to the outlet, and they make AC outlets with little plugs on the back, for high voltage AC. So I can put AC out in the front to all my, endpoints in the house that still need power. Maybe we haven't gotten the TVs made PoE yet. Maybe there are other devices you need to plug in AC power, and we can still provide that in the home. So as far as the reliability of it and the network of it, I see this going into, so everybody already has, in your own home, you might have like a little router, and AT&T sends you the router, you install it, or they come and send someone to install it. And then if you have a problem, you call that number and they fix it for you from a distance. This is exactly how I see this working in the future with PoE. Somebody has outside access to this, some kind of service, whether it's, us or a 24-hour operations center. They send you that router. They have access to seeing, any problem you might have. If you're having an issue, you can call them and they can either fix it, via the internet, like over, from their offices, wherever they are. Or if it's, something greater, they can send somebody out to that area and fix it for you. So that's kind of the way that I see this working in a residential standpoint, is that it would be just like what you see with AT&T nowadays, sending out a router to you. Very simple, very common, I think, factor with how they they run their operations. But that's how I would see that working. But I just think it's so compelling with when you calculate out the load that it takes to run a house, and with the energy efficiency of solar now and other renewables, you could easily power everything in that home with DC power.
So are we still talking even within the confines of solid state? Have we gone beyond that discussion now?
Well, our mini bars are, solid state. So I think we can use a lot of that technology, to run some of these systems as well.
And if we're talking about direct current, DC power, I guess if Tesla had lived a little bit longer, he probably would have gotten here ultimately, right?
Right. Yeah, it's all back to, we went with AC, in the past, and now everyone just stayed with AC.
Right.
We've stuck with it. We put it in our buildings, we put it in our cities, but we've also cracked down on energy codes. And so because of that, all the manufacturers are like, well, how do we become more energy efficient? We build our products with DC. So now they're going back to DC, but we are still putting AC in the building.
Right.
And now, with all the new technology we have, we can change that. We don't need to keep putting AC. We have the tools we can utilize to power all the DC devices with DC.
So, I would imagine this is exactly where NASA's been going. Certainly Tesla has, from the current Tesla namesake, not Nikolai, but here we're talking about, I can't believe I've forgotten his name already.
Elon.
Thank you very much. I imagine, well, let me just ask you, have you guys connected?
Well, it's a little hard to get a hold of Elon Musk, but they are, we've been working with Jacobs. They right down the street from us here, and they're building their new factory in Austin. And so we've been trying to worm our way into getting an introduction, but COVID's put a little bit of a damper on that.
Sure.
But
it seems that this is really right up his alley. If you take a look at, even as we're currently even thinking about trying to inhabit Mars and any other M-type planet or N-type planet, this is really where it needs to go. It does seem to be the most efficient, most cost-effective, ultimately, method to run.
And one interesting thing that we found is, so the RV and boating industry all runs off of DC power, low voltage. And so, we've been like, oh, how can we find a ceiling fan? And it's like, oh, well, here's one that's supposed to go in an RV and it's already 24 volt DC. We're like, oh, we'll just use that. So in our Marcel project, we found a small mini fridge that's just 12 volt DC because it's meant to go in an RV. And we're just going to power that with PoE and put it in. So there's a lot of industries that are kind of already going that direction.
Right.
RV industry already has a lot of light bulbs developed. So I can use that light bulb instead of a typical AC light bulb, and it works perfectly with our system. So it's interesting. It's kind of like sneakily been happening behind the scenes. And we didn't realize it.
Well, and I think that this is, if Nikolai Tesla had come back, he would be saying, finally, y'all figured it out.
Right.
So having said that, who's smarter, Edison or Nikolai?
My boss would kill me if I didn't say Tesla. So. But it's interesting, there was an article that was put out, I should probably know who wrote it, but I can't remember right now. But they were talking about, why has this happened now? Why is low voltage DC coming back? And they pointed to three things. Renewable energy has become a lot more prevalent. It's become more efficient, better sources. People are understanding how to do it now more cost effectively. Battery industry, that's all DC power storage. And that has just exploded. You see the car industry, you see Tesla. So that's catapulted. And then the third item is LED lighting. So LED lighting is all, DC low voltage on the inside. And so with those three industries have just exploded and have given us enormous advantages for energy efficiency. That's why POE is making its entrance now, is because it's just connecting systems that are already, hugely used and have been advancing substantially with the technology they're using.
Well, so I guess to bring it home, and I appreciate everything you literally just now said, because I think that takes it down to its most elemental form of what we're talking about in terms of the kind of current we're dealing with here. So let's take it to another application real quick, and we'll make this the last question that that you'll be working with. And then we're going to go to another session that'll actually allow the audience to open up and ask you more questions. But how do you see this technology being used in school facility design?
So we are actually, our partner Igor has done a few schools already, and it's really cool for schools. There's for a couple of reasons, because right now there's a lot of concern in schools, obviously with COVID, concern for health and safety. There's been a concern in the past few years about, active shooter situations. Mm-hmm. So when you can tie all the building systems together to make it safer for your students to be in a space, I'll give you an example. They've done a school in Alabama where they have gunshot detection systems located around the building. So when an active shooter situation happens, they can pinpoint exactly where the active shooter is. And from, each classroom send, a customized kind of information to that classroom to say their safest escape route. And that's because, the lighting is connected to the sensors, to the alarm panel, so it can send these more personalized systems out. I've seen a video they have done. They interviewed the teachers in the school after they put, and they did like a Kelvin tunable in there. And the teacher said, the students don't maybe realize it exactly, but when I am changing, when the color temperature is changing throughout the day, they're way more alert, they're way more attentive, they're focused, they're not losing their concentration because there are these subtle shifts with the light throughout the day. And, these things are happening and they're not realizing it. So I think for schools, it's really interesting, the possibilities that they can have, and they're doing it at Round Rock. They've done it at a couple other places. I can get a list for the schools that have done it, but I think school is a really interesting use case to be looking at.
I'm glad that I asked that question. So thank you so much. So right now, and again, Hannah, gosh, thank you so much. I think that you'll find that, if you spend another hour with me, we'll probably go down so many other rabbit holes. But I really enjoyed my time with you. Certainly enjoyed asking questions that came from me, but also others from another screen that unfortunately you cannot see. But nonetheless, I appreciate the conversation. I appreciate the depth of your responses as well. Clearly, I could probably ask you 20 more questions and you'd not hesitate to answer them. So tell those who oversee you and what you do that they've done a very good job in employing you and bringing you onto their team. You did a phenomenal job. So thank you so much. All right, so what we're going to do, and Charlie, I know that I got you within earshot. What we're going to do is we're going to close out of this session and we're going to be going to our Meet the Speaker talk, and that's where we'll be getting connected with not only you, Hannah, but also with Rob Stelling. So again, thank you so much, and we're going to sign off here while we go to the WUVA session. So, and by the way, if anybody has any difficulty getting access to these face-to-face meetups from the agenda, please know that you can access it in the community tab on WUVA, the community tab under meetups. Okay, so go to the community tab and then you'll see another tab called meetups. All right, we'll see everybody on the other side. Thank you. Bye-bye.